Hello everyone! Did you know that black holes are actually very bright? For example, a supermassive black hole is a tiny object at the center of a galaxy, which consists of tens of billions of stars. But this tiny supermassive black hole at the center can outshine the whole galaxy by 100 times. Today I'm going to explain how this happens.
Mysteries of the universe.
First of all, let me show you the evidence. So these are the picture of a black hole at various wavelengths in X-ray, infrared, and optical, and then radio wavelengths. And all of these pictures show a very bright supermassive black hole at the center. So black holes are bright in all kind of wavelengths. But here, one thing to be cautious is actually the very center of the black hole is actually black. So this is a picture by the Event Horizon Telescope. And this is the first time humankind has taken a picture of the black part of the black hole. Within the event horizon, of course, nothing can escape. Even the light cannot escape the gravity of the black hole, so it will be black, as shown in this picture. What's bright, I say, is just the vicinity, surroundings of this event horizon of the black hole. This part is very bright and is sometimes called active galactic nuclei, or AGN. So why this AGN is bright? Let me explain. So this is a typical model of an AGN. So let's look at this, just the vicinity of the black hole in a red circle. So black hole, because of its gravity, attracts a lot of things around it. So many things around the black hole are gonna fall into a black hole. For example, gas or dust, sometimes stars, are pulled and then fall into black hole. When those things fall into black hole, because of the huge gravity of the black hole, these falling things are gonna release huge amount of gravitational energy. And then this energy is gonna become huge amount of radiation or high temperature. When things fall into the black hole, because things have angular momentum, those things are gonna form the so-called accretion disk around the black hole. See the red circle here? This accretion disk, because of the huge gravitational energy released, it's gonna be very high temperature and it has high rotation speed. The temperature of the accretion disk at the very inside can reach about million kelvins. That's how hot this is. Because this accretion disk is so hot, it's gonna emit in all kinds of wavelengths, such as X-ray or UV light or optical light. So accretion disks are very luminous. So if you look black hole in X-ray or optical or UV telescope, you see a bright radiation from accretion disk. And then let's look just outside the accretion disk. Then there's a dust torus. You look at this on right side or left side of the picture. This is made of dust. And then because in a very inside, close to the accretion disk, the dust is melted because of the strong radiation and high temperature from the accretion disk. So the shape of the dust is going to be a torus, like a donut. But so this dust torus is a little bit lower temperature than the accretion disk, but it's still around 1000 Kelvin. So this dust torus is going to emit strong in infrared. So if you point an infrared telescope to black hole, then you see a strong infrared radiation from this dust torus. At the center, perpendicular to the accretion disk, there's a jet. There are magnetic field, and along this magnetic field, there will be a jet. And in this jet region, there are high velocity charged particles such as electrons or protons are flying around. They are emitted from the black hole, and it's very high velocity. And then because there's a magnetic field, these charged particles are bended by the magnetic field, and then when they are bended, they will emit synchrotron radiation in radio wavelengths. So that's why these jets of the AGNs are bright in radio wavelengths. Also, the vicinity of the accretion disk and this torus area are filled with hot plasma gas. And in this area, there's radiation from so-called inverse Compton scattering. What is inverse Compton scattering? When there's a photon with lower energy, let's say optical photon, and then if there's a high-speed charged particle hits that photon, then photon's energy is pushed up to X-ray. This is called inverse Compton scattering. And because of this effect, this vicinity around the accretion disk also emits in X-ray. And this inverse Compton scattering also happens in these jet areas. So this jet area can also be seen with X-ray telescope. And this is why in X-ray, infrared optical radio, black holes or AGNs are bright in all kinds of wavelengths. In X-ray, you see the core of the accretion disk or inverse Compton scattering, and then optical, you see accretion disk. Infrared, you see the dust torus, and radio, you see the synchrotron radiation. That's how black holes are bright in all kinds of wavelengths. But there's another caution here. This kind of emission happens when things are falling into the black hole. If there's nothing to fall into the black hole, then black hole cannot shine very much. That black hole is not bright anymore. That is the case for the supermassive black hole at the center of our Milky Way galaxy. It seems the black hole at the center of our Milky Way galaxy is not so bright because there's not much material around it to fall into the black hole. So that's why researchers use the motion of the stars around the supermassive black hole to estimate the mass and then investigate this supermassive black hole. Okay, today I explained how and why black holes are so bright in the sky. If you like the video, please like it and then subscribe to my channel. Questions and comments are welcome down below. Thank you for watching the video. See you next time. Bye bye.